All right, so this is polynomials, adding, subtracting, multiplying, stuff that we've probably seen like 100 times before, but we are in the month of June, so it is official, and I have to assume that you've forgotten everything, unfortunately. So let's just go ahead and do some, let's just do some of these, and then hopefully I can point out at least some shortcuts along the way for a couple of these examples, and then we should be able to, this will be just one more kind of tool in the belt for when we get around to SAT practice. So let's look at number 1, and no pressure or anything, but I want to kind of ease us into, and I want to show you by example of how timing yourself on questions is a great way to kind of spur yourself into quicker evaluation. Stopwatch is when you're counting up, timers when you're counting down. So like when you're taking your SAT test, you'd set a timer for 3 hours that ticks down. When you're doing individual questions, I find it helps to use a stopwatch that starts at 0 and then you can stop it at, whenever you're done. See number 1, the cubic?
Yeah, okay, I should be ready.
All right, you ready?
Yeah.
All right, I'm gonna start the timer, go.
Okay, I think I got it.
All right, 38, very quick. What do you got?
X cubed minus 5x squared plus 65x minus 125.
Okay, I definitely agree with the first part and the last part, but let's see, how did you come up with your middle two terms? I'm looking at my window box for the second part. So we both get x cubed in the upper left minus 10x. That should be 10x squared, it looks like. Minus 10x times x.
Oh, that's what I did wrong.
There we go.
Oh, okay.
Hold on.
So it's minus 15x squared?
Hold on. There's one more problem, I think. Can you put it back?
Oh, okay.
And then I see minus 5x squared, 50x, 25x minus 125. Okay, so yeah, what do you get then whenever you fix that problem?
Okay, so I got x cubed minus 15x squared. And, see, x. 75x plus 75x.
Okay, yeah, that's what I get. One thing I want to point out is that there is a quick way to square things. Square the first term. So if this is A and that's B, right? And then there's usually an operator between there. There's always an operator, right? Plus or minus.
Yeah.
So that middle term is just going to be product of A and B, and it's going to retain the sign. So if it's positive, the middle term will be positive. If it's negative, the middle term will be negative.
Okay.
And then the last part is just squaring this term here, the B term, and what you need to remember about squaring is that it's always positive.
Okay.
So with that shortcut, you should be able to get, with this question and with like any other question, you should be able to get this part in like 10 seconds or less.
Okay.
And then you just multiply the resulting polynomial with whatever you were asked to cube one more time. Is that a little, let me turn that brightness down just a little bit on that. There you go. You should be able to see that a little better. And then, I always run out the window box. It looks like you do the same thing, but that's going to help you remember your signs and like your x squareds and stuff like that. So let's move on to number 2. So this should be like a half-minute or so question for you. I'm going to start the timer. You ready?
Okay, yeah, I'm ready.
All right, go.
All right, I'm done.
Nice. 10 seconds. What do you got? 11 seconds. What do you got?
9x squared plus 12x plus 4.
Perfect. And that AB times 2 shortcut is the way to get that middle term correct every time. Let's move to number 3. All right, so let me go to number 3. We've got 4x minus 3.
To the 5th power. Oh, yeah, okay.
To the 5th, yep. So what we can do really quickly is rewrite this as that squared
Okay.
right? That's all the same thing.
Yeah.
So then what that's going to do for us is it's going to let us reuse the work because we already have a quick way to do this. So then all we can do is take those kind of lightning calculations, window box those together, and we only end up having to window box twice. All right, so let's check it out.
Okay.
So we've got these, right? Let's just do one of them because the answer will be the same for both, right? Let's do it together. What's the leading term for like just one of these?
4x.
Right. But when you square it together, what's the leading term?
16.
16x squared, right?
Yeah.
Okay. And what's the middle term?
Would it be double the? Is it just 8x?
So we multiply a and b together. That'll give you what?
12. Negative 12.
Negative 12x, right? And then we multiply that by 2. So that'll be negative 24x.
Oh, okay.
Yeah. It's just a times b.
All right.
Yeah, it's just a times b times 2. If you glance back real quick at your work for number 1, look back at that window box that you did when you're squaring, you can see why this ab times 2 trick works, because when you do your window box, those like terms will combine on the diagonal, right?
Okay.
Like your 10x or the minus 10x part, this piece here.
Yeah.
That came from x times this twice, right?
Yeah.
Okay, I don't want to get too far off the path here, but that's why that works. So anyways, that's our middle term. And then what's our last term for this, if we're just squaring this once?
Which term? Oh, we're squaring the negative 3.
Yeah.
Oh, so then plus 9.
Plus 9. All right, so then we've got one of these things squared, and then we can just rewrite that. Right?
Yeah.
So then we basically just got this part here for free.
Okay, so then we just combine all those terms, and then that's our answer.
Right, yeah, exactly. But I just want to point out that by rewriting it this way as square, square, and then 1, that we did this in our head in like 10 seconds, and then we got this for free. So now we're moving on to iteration number 1 of the window box, but we really haven't even had to do a lot of manual work yet. And this is where you're going to really start lowering your times, and you're going to find that when an easy question like that, or like what may be a medium question to some people, you take a shortcut, bring that down to like an easy question. Now you have like an extra minute for the next hard question. And that's what's going to make the difference between... That's what's going to help raise your scores, that you're pretty much going to annihilate these easier and mid-tier questions, and then you're going to have time to think about these really hard questions that pretty much everybody's going to miss, except for you, because what you're going to be able to do is, even though you may not have like every single aspect of that question worked out, you're going to have time to sit and establish something about the answer. Like, is it positive? Is it, are the roots real or imaginary, right? Something about the answer, and then you're gonna be able to eliminate 2 choices, and you're making an educated guess, and sooner or later, your educated guesses are gonna be correct.
Yeah, okay.
All right, so this is how we raise our scores, is by getting much quicker at easier questions. It's not that we learned all this extra stuff, it's that we had extra time to sit and think about the really harder ones. All right, so come back to this. So now we're gonna window box these guys. And I like to do these together, not this one, because it's easy to square things. And when you got all kinds of different things going on, that's where you open yourself up for error. Would you agree?
Yeah.
Okay, so 16 times 16, 256. And that'll be x to the what?
Well, the 4th.
X to the 4th, very good. And then we got 16 times negative 24, negative 384, and that'll be x to the what?
X to the 3rd.
X to the 3rd, right? And then we've got 9 times 16. That'll give me 144. I want to do another exercise with you too, another lesson, another day on mental math and how to kind of expedite that.
Okay.
It's particularly helpful for the SAT calculator inactive and just life in general, being able to do a little bit of math in your head. But that's kind of a lesson for another day. All right, so now, again, what I really like about doing these exact same numbers is that we're going to be able to reuse this answer right here.
Okay.
And then we're also going to be able to reuse this answer right here.
Why is that?
Because here we did 16 times negative 24, and then here we're doing the same thing.
Oh.
See that? And then if you look at the 9 and the 16, that's the same process, and then that's the same process. So what you'll find is that it's much quicker to repeat the same process than it is to do a different process, and you're also significantly less prone to error.
Okay.
Again, it's all in the approach. We're not getting smarter with math per se. We're getting smarter at recognizing where humans make errors. It's when they do new or like a different thing. If you just do the same thing every time, you tend to not make mistakes. Right? So now we have this here, and we don't even have to push the buttons again on the calculator. We already know the answer. Can you see that okay? Should I zoom in a little bit? There you go.
Oh, no, that's perfect.
So we've got negative 384x cubed. And again, I want you to practice this before you really unleash this, because math is one of those places where like you find one shortcut and then you want to shoehorn everything into it. I would encourage you to become very fluent with the shortcut before you go around using it. But once you get good at it, this is going to shave so much time off of your math stuff. So again, we've got this number here. Now we've got a new one, negative 24 times negative 24. But you see how we're trying to minimize in a very algorithmic way how much actual work we have to do.
Yes, I do see that.
576, and that'll be x to the what?
X squared.
X squared, very good. And then 9 times negative 24, we haven't done that one yet, but we'll get to recycle that one once as well. So 9 times negative 24 gives me negative 216, and that's x to the what power?
Just x.
Just x, right? And then, like I said before, we're going to recycle this one because the numbers are the same, so that's 144. Whoops, and I forgot my x squared. Don't do that. And then we get to recycle this one here, right? 9 times 24, we just did that one. That'll be the same as this here, right? Because it's the exact same thing. Again, that's one more reason why I like to line up identical ones here for the window box, because we've just recycled 3 pieces of information.
Yeah.
So that'll also be negative 216x. And then 9 times 9 is 81. So if you look at this block as 9 pieces of information, so there's, let me make this note abundantly clear. So here we have 9 pieces of math info, right? 1, 2, 3, 4, 5, 6, 7, 8, 9. But how many calculations did we do? Well, we did 1, 2, 3, 4, 5, 6. We did 6 calculations. Right? We did the middle ones once, and then everything that's color-coded we were able to recycle one time.
Okay.
So we just reduced our work by 1/3. Pretty crazy. What if you could get that much more time on your SAT? You think your score would improve?
Oh, yeah, for sure.
100%, right? If I gave you an hour to do something and then I gave you an hour and 20 minutes to do something, I would 100% expect a better result for the longer time. So that's why we're going to algorithmically approach these questions. So now we just need to combine this all out. It's 256 x to the fourth minus, what's 384? Let's see, 384.
Oh, isn't it 768?
768. Yep, you're right. And then that'll be x cubed. And then you'll notice that I like to write these in the descending order, and hopefully you do the same thing. You definitely don't want them all over the place. And then our x squared term will be 576 plus 2 times 144, which gives me 864. And then you'll also notice, if you look across the diagonals here, you've got these yellows are both negative, the blues are both positive, the greens are both negative. So that's going to help you when you're combining these like terms, like your x cubes are all negative.
Oh, okay.
So your x term is also going to be negative. That's going to be minus 512x and plus 81. So like just all kinds of different ways of eliminating the possibility of error here. Look good?
Yeah, it looks good.
And then the last thing we have to do is just take this. I'm just going to copy and paste it. Again, you'll get these PDF notes at the end. And then we just need to multiply this by the original polynomial, which was what? I don't even remember.
5.
4x minus 3.
Oh, okay.
And in this way, this becomes the hardest part of the whole problem. Because this is pretty easy, right? This is only 8 blocks, or how many blocks? 10 blocks. But we can't really recycle any of this. So this will be the most time-consuming part of the calculation. So we got 256 times 4. I think that's what? 1,028? Let's see. Double check my computer math. 256 times 4 is 1,024. And that'll be x to the fifth. And then 4 times negative 768. What's the x? X to the what for that one?
To the 4th.
To the 4th. Very good. And then 864 times 4 is 3, 4, 5, 6. And that'll just be x. Oh, wait. Is that x squared? Did I forget that? Yes, I did. Hold on. Let me fix this. Okay, so that'll be x to the 3rd. And then we've got 512 times 4, that'll give you 2048 x squared, and then 81 times 4, 81 times 4, 324. And like I said, this is kind of just the tedious part. $768 times 3 gives me 2304 x third. 864 times 3 gives me 2592. Here we go. 512 times negative 3 gives me negative 1536. We're almost done. And then 81 times negative 3 gives me negative 243. So wrapping it all up, we get, oh, nope, that'll be positive. Oh, gosh. I'm already noticing one mistake here. I think I pointed out to you last time, Ty, how easy it is, like, despite having a math degree or despite, you know, whatever inclination advantage you think you have, that careless errors never really go away. They're very, very sneaky. You can definitely make mistakes. Doesn't matter how old you are. Doesn't matter how good at it you are, right?
Yeah.
Okay, so I need to go back and fix. I noticed that one and that one, and then that's correct. Okay, so let me go back and fix these. That's good. That's good. This one here is good. That one Does it just need to be positive or negative 25, 92, negative 46, 48 squared? Yeah, this one just needs to be negative. There we go. Okay. Not too bad. 1536 plus 324 is 1860x, and then minus 243. That is the answer that I'm sticking with. And if it's wrong slightly, that's not the point of this lesson. The point of the lesson is to show how to do these quicker. What do you think about the shortcut so far and the methodology?
It's a lot better, and a lot less time consuming.
For sure. So I will try to find like a worksheet that you can practice this on.